Hi there, welcome to the second video on the functions and graph topic. We're looking at the composite functions today. Okay, so three things we're going to look to do. Be able to calculate the output of a composite function at a given value, create a composite function given to the functions, and then identify the domain and range of composite functions, different things. Okay, so a composite function is essentially, just like when we looked at composite area, it was two areas put together. A composite function is two functions put together. So if you think about your function f of x takes you from x to f of x, okay, and then if f of x was then had another function applied to it, like a function g, that is two functions acting kind of one after the other. The composite function there is the one that goes directly from the start to the end. That's your g of f of x. Okay, so g of f of x means you're applying function g to the function f of x, which happens first. Okay, so we've got two examples here looking at f of x is equal to 3x and g of x equal to x plus 3, being able to find the value of f of g of 2. Okay, and I want you to pay careful attention to that language, f of g of 2. Okay, so firstly, we need to know what g of 2 is. You work from the inside out. I want to know what g of 2 is here. Okay, so g of 2, we know this from our National 5 stuff. G of 2 is going to be 2 add 3, going from this function here, okay, which is 5. So if I'm doing f of g of 2, that means I'm doing f of 5, which means I'm doing 3 lots of 5, which is 15. Okay, so you can see the composite function. Firstly, we're doing g of 2, and then we're putting that value into our function f. Okay, same here, we're doing g of f of negative 1. So firstly, we need to find out what f of negative 1 is. So 3 lots of negative 1, which is negative 3. Okay, and then to find g of f of negative 1, we're then doing g of negative 3, because that f of negative 1 is equal to negative 3. Okay, so it's negative 3 plus 3, which is equal to 0. Okay, now that's evaluating composite functions at a given value. We know what x is, basically. We know it's 2, we know it's negative 1. Okay, it just means you're doing one function first. In the first case, f of g of 2 means you're doing the g of 2 first, and then f. And g of f of minus 1 means you're doing f of minus 1 first, and then you're applying the function g to it. Okay, now the one that's a lot more common, that's the ones I've just done. One that's a lot more common is when you have two functions, you're not given a specific value, and you're asked to create the composite function. So here, 2a, we're looking at finding f of g of x, and for part b, we're looking at finding g of f of x. So you can see where the kind of difference there. On the first one, you're doing the function g first, and the second one, you're doing the function f first. Okay, now f of g of x literally just means we're doing f of whatever g of x is. So in this case, g of x is x squared plus 2. Okay, so we are doing f of x squared plus 2. And the same way, if you change that input from x to 5, you'd swap a 5 in. All I've done is change input from x to this x squared plus 2. So for that f of x, I'm just going to replace that x there with my function g of x. Okay, so that f of x plus 2 really means x squared plus 2 plus 1. Okay, the same as here, it's x plus 1. Well, that x changes to an x squared plus 2. Okay, there's nothing happening to that bracket, so I can just break out it straight away and add 3. So that x squared plus 3 is your f of g of x. Okay, for b, we're doing g of f of x, which really means we're applying the function g to this x plus 1. Okay, and then going back to my function g, where that x is just going to be an x plus 1, sorry, it's going to be an x plus 1 squared plus 2. So instead of having an x squared plus 2, we're turning that x into an x plus 1. Okay, and that's just a bracket that can simplify. X squared plus 2x plus 1, when you multiply that bracket, add the 2 at the end, becomes x squared plus 2x plus 3. Okay, big point here, notice that g of f of x is not the same as f of g of x. Okay, it matters what way you do that. Okay, a couple more examples. I'd encourage you to pause the video now and give it a wee try. Okay, so 3a here, we're doing f of g of x. That means we are doing f of x squared plus 2x plus 3. Okay, and write down this line. You get a mark for knowing what this means. Okay, so f of g of x means you're doing f of x squared plus 2x plus 3. So in the function f up here, that x is going to be replaced by this x squared plus 2x plus 3. So it's literally sine of x squared plus 2x plus 3. Okay, a bit messy there in my squared, but x squared plus 2x plus 3. No simplification to be done. That's us. Okay, g of f of x. Okay, same idea. We're going to be doing g of sine x. Okay, which means in the function g, every x is going to be replaced by sine x. Okay, so firstly, it's sine x squared, then it's 2 lots of sine x, and then it's plus 3. Okay, and just to tidy that up a little bit, I'm just going to do it as sine squared x plus 2 sine x plus 3. Okay, again, not the same thing as f of g of x. Okay, now you're going to get lots of practice with that. It's a very common exam question. It'll almost certainly come up in your exam. Okay, but it's just the same process, and make sure you're doing this line here where you write out as g of sine x and then substitute it in, just in case you mess up that second line. You don't want to ship that first mark. Okay, last one, a little bit trickier. Okay, so if f of x is equal to x over x plus 1, part A is finding h of x, where h of x is equal to f of x. Okay, giving you an answer in its simplest form, which will just be a little bit of algebraic manipulation. And then part B, state a suitable domain for h of x. Okay, I'm just going to give a little bit more room. Okay, so here I'm wanting to find h of x, which we know is f of x. Okay, so h of x really is just a bit of unnecessary admin there. You're trying to do f of x. Okay, which means you're substituting x over x plus 1 into f of x. So you're substituting something into itself. Okay, so that means everywhere you see an x in your f of x there is getting replaced by x over x plus 1. Okay, so x over x plus 1 divided by x over x plus 1, add 1. Okay, and I'm going to do just a little bit of work at the side here to simplify this. Okay, so right now, that's you done the kind of maybe 2 out of 3 marks there for that. Okay, and you've done the kind of higher bit. The last bit is just simplifying algebraic fractions, which you have done at National 5, but kids always kind of do poorly with this question. Okay, so you're doing x over x plus 1, add 1. Okay, we know to add fractions, we need the denominators to be the same. So we're doing x over x plus 1 plus x plus 1 over x plus 1. And then adding along the top line, you're getting 2x plus 1 divided by the denominator, which is x plus 1 there. Okay, so that's the first thing there. You can turn that bottom fraction into a single fraction. So it's x over x plus 1 divided by 2x plus 1 over x plus 1. Okay, and then secondly, there's 2 ways of thinking about this. Either you can do this fraction as a divide, or if you multiply the top and bottom of a fraction by x plus 1 here, notice how they're both being divided by x plus 1. If you multiply top and bottom by x plus 1, on the numerator, that will cancel out the x plus 1 on the bottom and just leave you x. And on the denominator, it will cancel out the x plus 1 and just leave you 2x plus 1. Okay, so that is your simplified fraction. Okay, so you'll get 1 mark there. Well, you should, depending on the marking scheme. You get 1 mark for knowing to do this, 1 mark for subbing it in, and then your 3rd mark for your simplification. Okay, now part B, state a suitable domain. Okay, so state a suitable domain. Well, we're looking at a fraction, and we know that fractions cannot have a denominator of 0. So 2x plus 1 cannot be 0, which means 2x isn't negative 1, which means x isn't negative a half, or cannot be negative a half. So your domain is x can be anything, your real numbers, but x cannot be negative a half. Okay, you'll get your mark just for x equals negative a half, but may as well do it properly. Okay, so 3 things we need to be able to do: be able to calculate the output of a composite function at a given value, so evaluating stuff like f of g of 2. Okay, part B, being able to create a composite function given 2 functions, so that's pretty much the bulk of this. That's the thing that will almost certainly be examined, just finding f of g of x or g of f of x, and identifying the domain and range, just applying stuff from the last video in terms of identifying the domains there. Okay, well, thank you very much.